Hello students, welcome to Time Classes. In this short session, we discuss about Nernst equation from electrochemistry. Let's start the session. Nernst equation. This equation gives a relation between electrode potential and concentration of the electrolyte. In an electrochemical cell, a redox reaction can take place. Here I have taken a redox reaction. Assume it is a redox reaction. A and B reacts with each other and produce C and T. A and B are reactants, C and D are products. Assume it is a redox reaction. So before applying the Nernst equation to this reaction, we should know what is the Nernst equation. The Nernst equation is E cell equal to E naught cell minus 2.303 RT upon NF multiply with log Q. What is Q? Q is a reaction quotient. So you should know the terms in the Nernst equation. E cell is EMF of the cell. E naught cell is called standard EMF of the cell. What is Q? Q is a reaction quotient. How can we calculate the reaction quotient? When you are considering molar concentrations, QC, that is equal to product or ratio of product of molar concentration of the products to the molar concentration of the reactants. Now this reaction quotient is applied to this above reaction. Then the reaction quotient is equal to product of molar concentration of products, that is C and D, divided by product of molar concentration of A and B. Molar concentrations are denoted by a square bracket. During the reaction, small a, b, c, d's are number of moles of reactants and products respectively. So they become exponents to their molar concentrations. Molar concentrations. Now this Q value substitute in this Nernst equation. Then you will get E cell is equal to E naught cell minus RT divided by NF multiplied by log of ratio of product of molar concentration of the products to the product of molar concentration of the reactants. Now we should know some other terms in the Nernst equation. R is called a gas constant. The value is 8.314 joules per mole per Kelvin. T is the absolute temperature at 298 Kelvin, where F is a Faraday. What is Faraday? Charge carried by 1 mole of electron. 1 Faraday is equal to charge of 1 mole of electrons. What is the charge of electron? 1.602 into 10 raised to the power of minus 19 coulombs. That is the charge of an electron. Multiply with 1 mole of electron. 1 mole of electrons are equal to Avogadro number. So multiply with Avogadro number. 6.022 into 10 to the power of 23. And after multiplication, the final value is approximately equal to 96,500 coulombs. The term 2.303 RT divided by F, that is equal to 0.0591. That value here you have to substitute, where N is number of electrons transferred during the electrochemical cell reaction. Therefore, at 298 Kelvin temperature, the final Nernst equation you will get is E cell equal to E naught cell minus 0.0591 divided by N multiply with log Q. Now, how this Nernst equation is applicable to different electrodes and cells that we have to see. Here I am applying this Nernst equation to this half cell. Half cell is nothing but electrode only. Here I have taken a metal electrode. In the metal electrode here, metal ion is reduced. So Mn plus ion is reduced to metal. So for this reaction, what would be the reaction quotient? Reaction quotient is equal to, here product concentration is what? Here M is a product. So molar concentration of metal divided by molar concentration of metal ion. But metal is in solid state. So molar concentration of metal is taken as 1 unit. Taken as 1 unit. Therefore, the reaction quotient become 1 by molar concentration of Mn plus ion. This value I have to substitute in this Nernst equation. Now you see, this is a Nernst equation. In this equation, we calculate electrode potential of the metal. So E Mn plus ion to M, because Mn plus ion is reduced to metal. That is equal to E naught Mn plus ion to M minus 0.0591 by number of electrons transferred n log of the Q value I have substituted 1 by Mn plus ion molar concentration. Now this Mn plus ion concentration move to the numerator, then minus become plus. So the second term here become here plus. Then you will get log of Mn plus ion concentration multiply with 0.0591 by n. This term is added to this standard electrode potential of the metal electrode. So all the values if you know here, then you can calculate the electrode potential of the metal electrode. Here E Mn plus ion to M is called electrode potential of the metal electrode. Next E naught Mn plus ion to M is what? Standard electrode potential of the metal. Next we discuss how the Nernst equation is applicable for gaseous electrode. Hydrogen electrode is a gaseous electrode where we use a platinum as an inert electrode. So generally platinum is used as an inert electrode for gaseous electrode. For this gaseous electrode, the cell reaction is 2H plus ion plus 2 electrons gives rise H2. This is a balanced equation. H plus ion is reduced to H2. Now what would be the reaction quotient? Reaction quotient Q is equal to partial pressure of hydrogen divided by molar concentration of H plus ion, molar concentration of H plus ion whole to the power of 2. Because number of moles of H plus ion is 2 now. So become an exponent to this molar concentration. Now at 298 Kelvin temperature, the Nernst equation is, so EH plus ion to H2 is equal to standard hydrogen electrode minus 0.0591 by 2. 2 is what? Number of electrons transferred during the electrode reaction. Multiply with log of pH2 by H plus ion concentration. Here, the standard hydrogen electrode value is always 0.00 volts only. Minus 0.0591 by 2. Here, assume partial pair of hydrogen gas is 1 bar. Then log of 1 by H plus ion concentration. When it moves to the numerator, when it moves to the numerator, 0.00 volts na 0 minus 0.0591 by 2. Multiply with 2 into minus log of H plus ion concentration you are getting. Here this two term get cancelled and you will get minus 0.0591. Negative logarithm of H plus ion concentration is called pH. So thus we can calculate electrode potential of this hydrogen electrode. Here, if you know the pH value, you can calculate electrode potential of hydrogen electrode. If you know the electrode potential value, you can calculate pH. Where pH, if you know, you can calculate H plus ion concentration by taking this formula. pH is equal to negative logarithm of H plus ion molar concentration. If you want to know H plus ion concentration, that is equal to 10 raised to the power of minus pH. The pH value here is substitute. You will get H plus ion concentration in molar. Okay. Next. Now we apply Nernst equation for a complete cell. Here I have taken a cell, complete cell. A Daniel cell I have taken here. This is a complete cell. In this cell here, a redox reaction is taking place. Now in the Daniel cell here, two electrodes are there. One is zinc electrode, and the other one is copper electrode. These two electrodes are separated by SR, denoted by two vertical parallel lines. Zinc electrode act as a anode. Copper electrode act as a cathode. At anode, always oxidation reaction takes place. Now the oxidation reaction take place at anode. So the electrode potential of anode is called oxidation potential, and the electrode potential of cathode you consider as a reduction potential. Okay, so now we calculate oxidation potential of anode and reduction potential of cathode. Both, if you add, you will get EMF of the cell. But here we may get confused here. So the oxidation potential values you have to convert into reduction potential value. Therefore, for same electrode here, the oxidation potential value is always equal to reduction potential value, but sign will be differed. E oxidation potential is equal to minus of E reduction potential. Here oxidation potential for an anode you take, that is converted into reduction potential, therefore minus of ERP of anode. Now this value substitute in this above equation. What you will get? An EMF of the cell is equal to electrode potential, reduction potential of cathode minus reduction potential of anode you will get. Here cathode is what? Copper electrode. So reduction means what? Cu2 plus ion reduced to Cu. This is a cathode. Now the reduction potential of anode means what here? Zn2 plus ion reduced to Zn. So this is for anode. So that is only is given here. E cell is equal to E Cu2 plus ion to Cu. This is a cathode and this is anode. Both are in reduction potential values. So cathode minus anode you have to do. Here how to calculate E naught cell? E naught cell value is also same like that. E naught cell is equal to E naught reduction potential, standard reduction potential of cathode minus standard reduction potential of anode you have to take. Then that E naught value you substitute over here. Minus 2.303 RT divided by 2 into F. 2 is what? Number of electrons transferred. Cu2 plus ion reduced to copper. Zn2 plus ion reduced to zinc. So number of electrons transferred here is 2. Is it? So N is equal to 2. Multiply with log of. Here Zn2 plus ion concentration by Cu2 plus ion concentration. How you will get here this Q value? You will get a cell reaction. What would be the cell reaction here? Here zinc electrode is a anode, so zinc get oxidized. Copper electrode is a cathode, so Cu2 plus ion reduced to Cu. So now the overall reaction I am writing here, zinc reduces Cu2 plus ion to Cu, and Zn2 plus ion itself get oxidized to Zn oxidized to Zn2 plus ion. This one. In this case here, molar concentration of zinc is taken as 1 unit. Here copper is also in solid state, so you have to take 1 unit. Okay, now we consider the reaction quotient Q is equal to product concentration, that is Zn2 plus ion concentration divided by Cu2 plus ion concentration. This value I have to substitute over here. So final equation you will get this. Thus we can calculate EMF of the cell. Next, electrochemical cell and Gibbs energy of the reaction. See, in an electrochemical cell, electrical work done is equal to the electrical energy. Means, if suppose in an electrochemical cell, if the cell reaction must be feasible, it should be a spontaneous. Then the free energy change must be less than 0. Then the electrochemical cell reaction is feasible. So whatever the cell reaction is taking place, it produces electricity. So certain work has been done. So that is called electrical work energy. That electrical work energy is mentioned in free energy change. That is always negative, then it would be a spontaneous reaction. Then it would be a spontaneous reaction. Now you see, how can we calculate electrical energy or electrical work energy? The electrical work energy delta G is equal to the product of quantity of electricity flowing in the circuit and the EMF of the cell. So EMF of the cell is denoted by E cell. Multiply with the quantity of electricity. Electricity is calculated in Faradays. So number of electrons transferred during the electrochemical cell reaction. Therefore, the quantity of electricity flowed in the circuit is NF multiplied with E cell, that is equal to delta G. If the reaction is spontaneous here, it must be negative. So delta G is equal to minus of NF E cell. If you want to calculate standard electrical work energy, so delta G naught is equal to minus NF multiplied with E naught cell. Now you see, in a reversible work done by a galvanic cell, that is equal to decrease in Gibbs energy. So delta G is equal to minus NF E cell. Standard cell potential are used here, then delta G naught is equal to minus NF E naught cell. Now, we discussed the derivation of Nernst equation. This Nernst equation is derived according to thermodynamics from Van 't Hoff equation. So what is the Van 't Hoff equation? Delta G is equal to delta G naught plus RT log Q. Here the delta G value and delta G naught value you have to substitute in this first equation. So after substituting the electrical work energy, delta G is equal to minus N of E cell. And the standard electrical work energy, delta G naught is equal to minus N of E naught cell. We get the Nernst equation. What is that? E cell is equal to E naught cell minus RT NF log Q. This equation you will get. Okay, now after these values, if you substitute, finally you will get this Nernst equation. Okay, now Q is equal to reaction quotient. And here point to remember, a natural logarithm is there, log Q, that is equal to 2.303 log Q base 10. So natural logarithm you have to convert it to log Q base 10 here. You have to multiply with 2.303. So minus 2.303 RT divided by NF log Q. Here Q is a reaction quotient. So after derivation of Nernst equation, here few points we have to discuss. Let's see. In the Nernst equation, if Q value is less than 0, the second term become positive. Then E cell value is greater than E naught cell value. If Q is less than 0, delta G will be less than 0, then the reaction is feasible. If Q is greater than 0, then E cell value is less than standard EMF of the cell. If Q is equal to 1, then log Q will be 0, then the second term whole it is become 0. Therefore, E naught cell value is equal to E cell value is equal to E naught cell. Point to remember of this one. Okay, next. Now we discuss the equilibrium constant from Nernst equation. Here a redox reaction I have taken. A reacts with B, gives rise C and D. Now apply the Nernst equation for this reaction. So E cell is equal to E naught cell minus 2.303 RT by NF log Q. Here at equilibrium state, delta G is always 0. At equilibrium state, delta G will be 0. If delta G is 0, E naught cell is also 0. Then the reaction quotient become an equilibrium constant. Now, E cell is 0, na? Then you will get E naught cell is equal to 2.303 RT by NF multiply with log K. K is a equilibrium constant. If you know the E naught cell value, you can calculate equilibrium constant. If K value if you know, you can calculate standard EMF of the cell. Okay, na? So final this term 2.303 RT by F you will get 0.0591 by N multiply with log Kc, that is equal to E naught cell. This is a relation between E naught cell and the equilibrium constant. Here point to remember, if Kc value is greater than 0, then E naught cell value is greater than 0. If Kc value is less than 0, then the E naught cell value is less than 0. If Kc value is equal to 1, then E naught cell value is equal to 0. Okay, next. How the Nernst equation is applicable for electrolyte type concentration cells. See this one. This is a general electrolyte type concentration cells. Both electrodes two metal electrodes I have taken. Both are same electrodes, but the electrolytes are at different concentrations, C1 and C2. Therefore, this cell is called electrolyte type concentration cell. For example, here two zinc electrodes are taken here, and Zn2 plus ion zinc sulfate concentrations, aqueous zinc sulfate concentrations are at different. One is at C1, another one is C2. Left hand side act as a anode, right hand side electrode act as a cathode. For any electrolyte type concentration cells, E naught cell value is always 0. Then E cell is equal to you will get minus RT by NF log Q. Q is what here? Here concentration you have to take. Here product what is the cell reaction here? The cell reaction is Zn2 plus ion aqueous to Zn2 plus ion aqueous only you will get. Okay, now this Zn2 plus ion belongs to what is that anode, and this Zn2 plus ion belongs to cathode. For anode here the concentration is C1. Here the concentration is C2. You take cathode. In cathode electrode here, Zn2 plus ion concentration is C2. In anode, Zn2 plus ion concentration is C1. So product is what? Zn2 plus ion of anode. So that is C1 divided by Zn2 plus ion, aqueous Zn2 plus ion concentration, that is C2 for cathode. Wasted. Now C2 move to the numerator, C1 come to the denominator, minus become plus. Then what you will get here? EMF of the cell is equal to RT by NF, minus become plus. So log of C2 by C1. Here C2 move to the numerator and C1 come to the denominator. Then minus become plus. Okay, na? Now here C2 is what here? E cell is equal to RT by NF log of. C2 is what? Cathode solution. C1 is anode solution. Thus we can calculate EMF of the cell. So E cell is equal to RT by NF log of cathode solution by anode solution. This formula you have to remember. Now we discuss some questions which are given in the previous entrances. Calculate EMF of the given cell. In this cell here, this is a zinc electrode taken as a anode. This is also a zinc electrode taken as a cathode. So both are zinc electrodes taken as anode and cathode. Left hand side is anode, right hand side is cathode. But the Zn2 plus ion concentrations are different. Electrolytes are at different concentrations. Therefore, this cell is electrolyte type concentration cells. For this electrolyte type concentration cells, E0 cell value is always 0. That you have to take. Now we have to solve. Here, first you have to write the cell. Okay, what is a electrolyte type concentration cells? What is the EMF of the cell formula? E cell is equal to RT by NF log. Cathode solution is what here? What is the cathode solution? Zn2 plus ion. Okay, na? Zn2 plus ion concentration, cathode solution, divided by anode solution, Zn2 plus ion of anode solution. Okay, now this value you will get 2.303 RT, na? RT divided by F, that is equal to 0.06. This value here you have to take 0.06 divided by N, and the log of cathode concentration is what? 2. And anode, in anode here electrolyte concentration is 0.0002. Wasted. Okay, na? What is the term here? How many times here? You will get 0.0001. Now this one you can write 0.06, number of electrons transferred 2, and log of 1 by 10 to the power of minus 4. Wasted. Okay, so from this one you see here E cell is equal to 0.06 by 2, and the log of 10 to the power of 4 when it moves to the numerator. Okay, na? Then what you will get? 0.06 by 2 into 4 into log 10 wasted. Here how many times? Here it cancel here 2. So 0.06 multiply with 2, you will get 0.12 volts. Here this value is approximately 0.12 volts. Actually here 0.0591 if you take this, then this value you are getting. So option 2 is the answer approximately. Next, for the reaction, for this reaction here, thallium reduces Cu2 plus ion to Cu and itself it gets oxidized. Cu2 plus ion concentration is 0.01 molar and thallium plus ion concentration is what? 0.001 molar concentration. EMF of the cell is 0.56. When the E cell value increase, here point to remember, E cell is equal to E naught cell minus 0.0591 by number of electrons transferred and log product concentration. Here, what are the product here? Thallium, now. Thallium plus whole square by Cu2 plus ion concentration. Best. Now, simply you see, if Q value is less than 0, then E cell value is greater than E naught cell value. Because if Q value is less than 0, the second term will become positive. Second term become a positive. So that here, when Q will be 0, Q is equal to thallium plus ion whole square by Cu2 plus ion concentration. When Q will decrease here, when the concentration of Cu2 plus ion increases. So that option 3 you see Cu2 plus ion concentration increases here, E cell value will increase. E cell value increases. So therefore E cell value increases. So option 3 is the answer. Next. If EMF of hydrogen electrode at 25 degrees centigrade is 0 in pure water, then the pressure of hydrogen in bar is. Hydrogen electrode, na? So hydrogen electrode means what? 2H plus ion. By gaining of 2 electrons, reduced to hydrogen. This is a gas. Okay, what is the reaction quotient? Reaction quotient is equal to partial pair of hydrogen gas divided by molar concentration of H plus ion whole square. You have to calculate partial pair of hydrogen gas. Here H plus ion concentration we should know. Here the electrolyte is a pure water. So for pure water, H plus ion concentration is equal to OH minus ion concentration. That is equal to 10 to the power of minus 7 molar concentration. So H plus ion concentration is 10 to the power of minus 7. Now apply the Nernst equation. What you will get here? E H plus ion to H2 is equal to E naught H plus ion to H2 minus 0.0591 divided by number of electrons transferred. Here it is what? 2. 2 electrons are transferred. So N is equal to 2. Number of electrons transferred and log of partial pair of hydrogen divided by H plus ion concentration is 10 to the power of minus 7. Minus 7 whole square. Okay. Standard hydrogen electrode value is 0. EMF of the hydrogen electrode at 25 degrees centigrade is also given 0. So minus 0.0591 by 2 and log of partial pair of hydrogen by 10 to the power of minus 14 is 10. Now what you will get here? What you will get? Log of partial pair of hydrogen by 10 to the power of minus 14. Minus if you take, this value is equal to 0. So log of 10 to the power of minus 14 divided by partial pair of hydrogen, that is also equal to 0. I have moved to the numerator, and this one 1 by pH2 by 10 to the power of minus 14 is also equal to 0 only. Minus become plus. Okay, if you take anti-logarithm, then 10 to the power of minus 14 by partial pair of hydrogen is equal to 10 to the power of 0. 10 to the power of 0 is nothing but 1. Then you calculate partial pair of hydrogen, that is equal to 10 raised to the power of minus 14. This is in bar units. So answer would be first option. Okay, next. The cell potential for the given cell at 298 Kelvin is 0.31 volts. The pH of the acidic solution is found to be 3, whereas the concentration of Cu2 plus ion is 10 to the power of minus x. X value calculate. So EMF of the cell is what? 0.031. Okay, now first you have to write the what is that? Sorry. First you have to write the Nernst equation. What is the Nernst equation here? E cell is equal to E naught cell minus 0.06 by number of electrons. Here how many Cu2 plus ion to see, 2 electrons are transferred. We write the balance equation, by that we can know. And log of product concentration by reactants, that is a Q. So here Q you have to write. What is a Q here? First you have to write the balance equation. Here H plus hydrogen gas reduces Cu2 plus ion into Cu, and itself it get oxidized to H plus ion. This is aqueous and this one is solid. This is also in aqueous state and hydrogen is in gaseous state. So these are the reactants. This is a product. This one you have taken molar concentration of copper is taken as 1 unit because it is in solid state. Okay, now you see this one you have to apply. What is the cell potential of this cell here? That is 0.31. So 0.31 is equal to E naught cell value you have to calculate. This is anode, this is cathode now. So what you will get here? E naught cell is equal to, okay now, E naught of reduction potential of cathode minus E naught reduction potential of anode. Copper electrode potential value here it is given here 0.34 volts. This is a standard one. Minus standard reduction potential of hydrogen electrode is taken as 0. Anode is what? Hydrogen electrode. So that is taken as 0. So E naught cell value is 0.34 volts. So 0.34 volts minus 0.03 and log Q is what here? Q here it is H plus ion concentration whole square divided by partial pair of hydrogen into Cu2 plus ion molar concentration. Here partial pair of hydrogen, here it is 1 bar, pressure is given. Okay na? And pH is also given. What is pH here? pH is equal to 3. Then H plus ion concentration is equal to what? 10 to the power of minus pH. So 10 to the power of minus 3 molar concentration. Is it? So you will get here, you bring this side here, what you will get? Minus 0.03, that is equal to minus 0.03, and log of H plus ion concentration is 10 to the power of minus 3 whole square, means 10 to the power of minus 6 divided by 1 into molar concentration of Cu2 plus ion. Wasted. Minus get cancelled. 0.3 get cancelled. If it moves to the numerator, what you will get here? Minus 1 is equal to log of Cu2 plus ion move to the numerator divided by 10 to the power of minus 6. This one you will get base 10. Okay na? So Cu2 plus ion concentration divided by 10 to the power of minus 6 is equal to 10 to the power of minus 1. So you will get Cu2 plus ion concentration is equal to 10 to the power of minus 7. that is Cu2 plus ion concentration is given, that is equal to 10 to the power of minus x molar. Therefore, x is equal to 7. So 7 is an answer. So these are the questions we discussed so far. I hope you understand the concept of Nernst equation and the questions we discussed in this session also. I hope if you like the video, you press the like button and subscribe. Thank you.